Well, welcome to our third workshop of the Exploring Learning Design series. Today we are on the feedback and assessment portion, and today we'll be talking about formative assessment. So, what do you guys think about these statements? Anybody agree with the first statement? As is? We're all faculty members. I bet we're all going to end up with modify all of these.
I mean, it's what we do. It's tradition, but that doesn't make it necessarily bad. I would say disagree.
You would disagree?
Yes.
Excellent. Why? Can you expand on that?
A graded assessment is the end of a process, and it doesn't give them a chance to improve from the process of assessment. So that's why I would disagree.
And I would expect you to have that inclination, because I think it's very true, and it works very, very closely with what you guys do, right? Is there anybody who kind of agrees with that assessment? No right or wrong answers?
I think depending on the subject and the type of understanding you're trying to measure, I think that graded assessment can actually be. I'm thinking I teach a physical chemistry class, the final exam does give me a pretty good idea of if they know how to do the problems or not. So I think in some cases it can be.
Or maybe in the midterm, it gives some incentive to achieve some learning regulation, right?
Right.
Yeah, looking at, you look at 100 finals from the same introductory Chinese class. Everybody gets the same grammar point wrong. You see that there's probably something either in the textbook or in the teaching style that would suggest that there's something didn't happen.
So for a faculty member, that serves as a really good diagnostic.
Yeah,
right?
I mean, if I'm
that helps you regulate what what you need to.
helpful for me.
Yeah, exactly. Excellent. All right. How about the second one? Anybody feel strongly one way or another, or do we all edit it, or? Yes, Sharon.
I was gonna say it could.
Okay.
But back to the first one, even graded assessments, students can have, if they have an opportunity to revise
Mm-hmm.
and learn from what, so if you build in revision,
Excellent.
even when grades are given.
That was one of our previous workshops on scaffolding. So yeah, scaffolding is a great concept to have, which is that you assign them a grade, but you give them a chance to improve on it, or you're sort of giving them feedback as they move forward. How about the last one? Self and peer assessment of work improves students' learning.
I find it's really variable in districts and class how well they get along.
Right.
In my classes, what do you know? Why do you have the right? Whether it's writing in their native language or obviously in a language, language classroom, it can be very variable.
Yep.
On how they get along.
Peer assessment, and actually that also feeds back to one of the other workshops we did, which was learning and community.
Yeah.
How about the self part? Did you?
I've never done that, but I know people do it different.
Right. Or they might do it all the way along, and that's how they're doing it, right? There might be self-quizzing as they study for an exam or something. All right, so with that said, let's move on because we're going to be a little bit short on time. Today, Mike Bloom is my colleague from Apple. We're going to have Jordan Walk up here in a second. He is a chemistry faculty member. We will have Jim Olver from Mason, and myself. I'm Pablo Yañez, in case you don't know, you've never met me. All right, so first up is going to be Jordan. Jordan I've actually worked closely with Jordan. When we decided to do a formative assessment workshop, I thought, man, that project that I've been working on with chemistry about video tutorials for students to prep for their courses would be a great one. I'm going to talk to Jordan to see if we can get him to come in. And he rushed over right from a class. So thank you, Jordan.
Yeah, so I had never heard of the topic before Pablo sent it my way. So I had to Google it, and after I read the Wikipedia page, or at least the first paragraph or so, I thought, yeah, actually that fits in perfectly, sort of. So I'm the perfect candidate for this. So anyway, I'm going to tell you a little bit about what we've been doing, why we've done it, and what the results have been, and if I'm happy or not, which I have been pretty happy. So what I've been working with is Chem 103 discussion. Hi. is Chem 103 discussion, and so that's General Chemistry 1. So it's discussion for the lab. We've got about 370 students. And the thing about general chemistry discussion is like I've put up there, there's just a general lack of experience as far as what the students have done. Some of them have done some lab work in high school, but a lot of them haven't. And so with those discussion sections, basically the main goal there is to number one, get important safety principles across. For a lot of them, first time they've been working with chemicals, and I want to make sure that everyone knows what to do and what not to do. And then after that, it's just general lab technique along with some important critical thinking skills, because you can't just go into lab and mindlessly stumble around. And so I do want them to have a good idea of what's going on. And so we've been under a little pressure within the department to actually get this thing out of the classroom and into an online format. And so the challenge was basically do all this, but do it without ever seeing them, and do it with about 370 students. And so I'll be honest, I was a little bit of a skeptic first leading in. I had some doubts with how effective this could be, and one of my biggest concerns was that I just wouldn't have their eyes on me. When they're looking at me, I can say important things. I always use the example, in chemistry lab, you don't want to say push this button because something bad will happen. They might not know that that button is bad, and so I want to see their eyes looking at me know that they should not push that button. And so I was going to miss that by going online. So that was one of my big concerns. And there's just, how could I get these pieces of key knowledge? There's lots of little nuances that I'm sure they don't remember, but I wanted to make sure that the big key pieces of information they remembered or they learned from the discussion, and so I was concerned that wouldn't work. So I said I was a skeptic, but I also thought after doing a week or two, because I wasn't ready to start with the semester, I did it in class for a couple of weeks, and I realized that this could probably be improved. And so notice that I also say I don't have their eyeballs when they were in the classroom either. I noticed that with such big classrooms or such big classes, I would have like a quarter of the students with their heads buried into laptops anyway. And so I had concerns in the first place of me being in the room with them was even as effective as doing something else could actually be. No one really liked discussion. I picked up on that pretty quickly. It was at a weird time, Monday and Tuesday afternoons at 3:30. No one likes to be in there at that point, so that was an improvement. It's hard to show a big classroom something. So for example, if I've got an intricate piece of glassware or an apparatus that they're going to need to put together, if they're 50, 75 feet away from me, it's hard to really get that piece of information across. It's hard for them to see it, and so if they could actually have that shown to them, that could be more effective. And then I had the final question, is actually being in the classroom as effective as I was thinking it would actually be? All right, so there's essentially three parts. So I've moved everything onto Blackboard essentially, and so there's three parts to this. There's 2 videos, and then there's assessment. The first video is more or less a discussion, and so it's a discussion on things like theory, the sort of things that I would generally do in the classroom as it is, what some students might consider a little bit boring from time to time, even if it's pretty important. Hopefully it's a little less boring by having them the opportunity to do it whenever they want to, so they're not stuck somewhere. Secondly, and I think this is one of the big takeaways from this, is that we can actually show them the procedure. So in the past, what I've done is I've stood in front of 160 people at a time, and I've said, this is what we're going to do, and I've talked through it, but that's not very visual and not very effective. And so what we've actually got now is videos where we have students in the chemistry department that have volunteered, and they've actually worked through the actual procedures themselves, and I think that's just a huge improvement. I'll show an example of how I think that's the case in a second. And then finally, there's an assessment, and I'll talk about the assessment briefly in here just a minute. So I've got three video clips here. The first video clip is sort of that, it's just a little bit of talk about theory. The second and third video clip are, I think, what I really want to highlight here. And so with the second clip, it's going to be essentially someone talking through an apparatus. The third clip is actually someone showing you how to set up the apparatus, which I think has been incredibly useful. So I'll play these.
The first property we really want to look at is temperature. So this basically is just a measure of how much energy is around, how fast are these gas molecules moving. It's important that we always measure our temperature in this lab in Kelvin. At this stage, we're ready to move on to investigate Charles' law. This is a little bit more of an intricate setup, so you need to be very cautious about the position of the plunger and how we clamp and set up the different apparatus. So we want to use a dry Erlenmeyer flask here. We're going to shut up.
For this Erlenmeyer, you're going to want to plug in this stopcock, and with your syringe completely depressed, attach it to the top of this Erlenmeyer flask. Now attach the Erlenmeyer, the tube coming out of the Erlenmeyer, to the pressure sensor. You should put the flask, the syringe, and the temperature probe all inside of this beaker. And when you turn on your LabQuest, you should see both pressure and temperature readings appear.
This is such an improvement to actually be able to show them a procedure that I can't believe we didn't think of it earlier. I think it's amazing. So then there's finally the assessment. And so with the assessment, here's an example of the assessment. I'll talk about the format of it in just a moment. And so there's key things. Like I said, there's those key topics that I want to make sure they understand. So for example, in a lab this week, they're going to be measuring out some natural gas into a flask. Now, natural gas is less dense than air, so if you put it into a flask, it's just going to go right up into the atmosphere. A number of times when we've done this lab, I know students have wasted their time because they didn't keep in mind they need to invert their flask and keep the natural gas trapped. And so, for example, you can see I've put a true or false question here, which basically just asks them, is it important that your Erlenmeyer flask is inverted? And so it's, I think, a more effective way to actually get that information across than telling them that, knowing that a quarter of the students aren't even looking at me. As far as that quiz itself goes, it's required, and as many of you probably know, you could make it 1%, and you're going to get 99% participation from the students. It doesn't have to count for much, just needs to count for a little, and they'll certainly do it. They have to have a perfect score. I want to know for a fact that at some point they have answered this question, true or false. There's also multiple choice questions that I'll put on there. I want to know that they've answered it, and for the most part, our success rate has been over 99% thus far this semester, which is better than actually when we had our attendance in an actual classroom. And so like I let off with, the goal is to not really assess with these quizzes. They can try it as many times as they want to. They just need to get a perfect score. And so I know many of them take it 3, 4, 5 times, but I want to make sure they come into lab having answered these questions and don't waste their or any of their lab mates' times. And so this leads into other ideas, not just safety. I think safety is the most obvious one, but technique and critical thinking as well. Again, I don't want zombies walking around in lab, and so I try to ask them questions that have to do with critical thinking, such that when they approach something new that they haven't seen before, they might have a little better ability to actually tackle that problem. And so I said I was a skeptic, but I'm here spreading the word now. I love it, and so I hope I haven't taken up too much time.
So we got a little bit of a late start, but any questions for Jordan? Before Jordan, you leave, don't leave. Any questions for Jordan? Yes, honey.
Are these post-lab?
These are pre-lab. So I post these. We have lab on Wednesday and Thursday. I post them the previous Friday. So if it's Saturday, even over the weekend, they can do the lab discussion and be prepared for the following week.
Are there post-lab quizzes?
So we have post-lab quizzes, not on Blackboard, but we actually have in-lab quizzes throughout the semester, 4 of those, which approach similar topics.
Because based on what you said, these are true-false kind of quizzes, so there's 50% chance for the student to answer it correctly.
Sure.
And if you want them to answer them correctly, they will answer them correctly, okay,
Right.
ultimately.
Right.
But if you put a post-lab quiz that is based on this one so that they have one shot at each question, then they will take it more seriously in this case.
Yeah, I think that's, I don't think by any means we're at a perfect state right now in this, because we just introduced it, but I think that's a good suggestion. I think there are definitely ways we can make it better. We're just trying to ease in right now, I think.
By sheer coincidence, my son, who is at UVA, had the good fortune of actually sitting in on Jordan's class right after we had finished doing this these videos. So I kind of watched over his shoulder. It was really interesting that he would take the quiz. If he got anything wrong, he would go back and watch the video again, not just sort of take the quiz again. He would actually go, wait, why did I get that? So there's this iterative loop that he would actually go through. And if he didn't get it right the first time, he might actually take it, believe it or not, more than once to get a perfect score to figure out why he had gotten something wrong. So it is, there's no replacement for the in-person lab, I think. But I think for some of these processes, it's if you're in a lecture hall with 250 students, the kids who are sitting in the back are not going to see how the connections are made, what the equipment looks like, et cetera.
I feared it would be a net decrease, and I think it's actually a net improvement. So.
Okay.